The retakes for Unit 5 were all updated, so that is reflected in your grade now, whatever your higher of 2 scores was. I think almost everyone improved on the constructed response part. For the illuminate part, I'd say it was like 60-40, like 60% of people did better. The other 40% just kept the original score, which is whatever. I mean, I always tell you in advance when the retake will be. Like I can even tell you, we haven't taken Unit 6 tests yet, but the retake will be like Tuesday after we take the first one. Does that make sense? So you need to make sure you're ready on those retake dates. Also, I had some people that just didn't retake a certain part of it. Why? I don't know. I mean, if you did like 25% the first time, I'm sure you could probably even just guess better and do a retake and get that over with, but I don't know why they didn't do it. So they're just at their original score, which was really not that great, like, not sure what happened there. Regardless, I still have tutoring this Wednesday, today. If you want to come by, maybe do corrections on your retake, or if you're one of those people that for some reason didn't do part of your retake, then you can go and retake that. But I still made a note of it in the grade book that a retake was offered to you. Just for some reason you didn't do it, whatever. We only get 3 unit tests a semester, so you gotta make each of them good. Right now, we're on Unit 6 though, so moving forward, this is the 6.03/4 practice. It was like a combo practice. And we're doing number 3. So say you're a rock star at all your practices and you don't need my help, that's fine. You can continue working quietly and by yourself, but unless you're like one of those kids that, I don't know, has an A in here and that already did all their practices, then I really shouldn't be doing things. All right, here's what your classmates are confused on, so odds are you might be confused on it too. So for this one, you had to write an equation to represent the relationship between the step number n and the number of small squares y in each step. So previous to this question, you had to answer how many squares there would be in like step 4, step 5, step 6, and then all the way up to like step 19 or something like far away like that. So what you should have done when you watch the video, boys, I need you to stop talking. What you should have done when you watched the lesson, and what you probably saw me doing in the lesson, was not really just trying to figure out the pattern in the shape, but just count the number of squares and find the pattern within the numbers. So like how many squares are in step 1? How many squares are there in step 2? How many in step 3? So 9. How many will there be in step 4? 12.
14.
16 is correct. Either, I don't know, figure out what they're doing. It looks like they're adding like a whole row almost, or find the pattern within the numbers. What do these numbers have in common? 1, 4, and 9.
They're all multiples of 3.
4 is not a multiple of 3. Technically, 1 is not either. What does anyone recognize 1, 4, and 9 as something? Maybe when we do 16, which is the correct answer for step 4. Now do we recognize what all of these numbers are? No. When something is squared. Actually, when the step number is squared. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. These are my first 4 perfect squares. And then the pattern continues. What's going to be my number of squares in step 5? 25. What about in step 6? That's the pattern, is they're squaring the step number each time. So to make the equation, you have to see like what is staying the same each time. They're squaring each time. right? But the step number itself is changing. So we're gonna use a variable for the step number, and they want you to use n for that. So it would be n squared, because that's consistent, they're squaring each time, equals the number of small squares y. By squaring each step number, we get the number of squares in that step. Does that make sense? Well, we know that quadratics in this unit, the minimum requirement is that they have an x squared. So start being able to recognize those perfect squares. Especially at least the first 12. Is what any math teacher would tell you. You can write it like this, or y equals n squared is also right. Questions on this one? Questions on any other unit 6 practices? Right, so question 7 on the same practice. Again, you're welcome to work quietly by yourself. If you don't need help with this one. But here it is. Function f is defined by f of x equals 1.5x. Function g is defined by g of x equals 500x squared because 345x. Which one is quadratic? Table 8, can you tell me which one's quadratic? F of x or g of x? G of x. What part of it tells me that it's quadratic? Table 9, can you tell me? What part of g of x makes this a quadratic? Come on, y'all, we just talked about it in the last one. Michaela? Not that adding necessarily, I mean, that definitely makes it not exponential. The x being squared is what makes it quadratic. That's your minimum requirement for a quadratic, all right? And if you graph both, you definitely see this one is the one that's in shape. But there you go, that's what makes it quadratic. That means by default, this one must be exponential, f of x. But we just did a unit on that, so hopefully that's familiar to you. When the variable is the exponent, that's exponential. And then which values, or the values of which function will eventually be greater for larger and larger values of x. That was a lesson 4 skill that you would have seen. Which one always grows faster? Quadratic or exponential? Exponential. That's like one of the properties, that's one of the things you need to know by the time you leave 9th grade, is that the exponential functions always overtake linear and quadratics. Maybe not at first, but eventually it always overtakes it. You graph them both if you really want to see, but that was something from lesson 4 that you should have learned. Stood there? Okay, other questions? From any unit 6? Yes, Michael? All right, so number 4 on the same practice. Okay, so for this one, which expression represents the relationship between the step number and the total number of squares in the pattern? You have a few things that you could do. You could count how many squares there are. So how many squares are there in step 1? How many squares in step 2? And how many in step 3? Now, if this is the correct expression and it's multiple choice, so I can try them all out, I should be able to plug in the step numbers and get the amount of squares that are there. Okay, so let's say I'm trying the n squared plus 1. If I'm plugging in step 1, So 1 for the n. What's 1 squared? What do exponents tell you to do? You could also put it in the calculator too, but these numbers aren't that bad, so I'll just do it with my hands instead of switching tabs. But what's 1 squared, guys? 1, because it's 1 times 1. And then what's 1 plus 1? That's not 0, right? So this first expression can't be my answer. So now I'm gonna try the other ones. N squared minus 1. If I plug in step 1, what's 1 squared? What's 1 minus 1? So it's working so far, see that it works for the other two. And then I still might have to check the other ones just in case, but if it works, if it's the right expression, it should work for all of these. So then if I plug in step 2 into option B, so that gives me 2 squared minus 1. What's 2 squared? What's 4 minus 1? So it's working so far. Last one I need to check. Step 3 is what we're plugging in to the n for the number of steps. What's 3 squared? And 9 minus 1 is, so it looks like the answer is this one. Consistently, especially because, as you can see, like, it makes a square. And then all they're doing is subtracting one of the squares. That's additionally why it's that. Make sense? Yeah,
Section.
yes. Other questions at all? Hello. All right. Each figure is composed of large and small squares. The side length of the large square is x. And we need to write an expression for the area of the shaded part of each figure. So what do we know about finding the area of a square? Table 1, can you tell me how do I find area of a square? Length times width is one way that you can say it. Table 2, what do we know about squares? What's unique about squares especially? Like what makes a square a square? 4 sides that are all, so in that case, you could also do, instead of length times width, you could just do side length squared for your area, right? It's kind of like a big property of this unit is that it makes a square. But it gave us some other information, like that the side length of the large square is x. So in figure A, my side length is x. Since it's a square, this side length is also x. Length times width, x times x. What's my area of this large square? Class? It's length times width, x times x. What's my area of the large square? I know you guys are in 9th grade, but this is like section. It's like asking you 1 plus 1. If I have x times x, what does that equal? Not x, John? So x squared is the answer I was looking for. Okay, guys? or x to the second power also works, but x to the first times x to the first is x squared. That's your exponent rule. Remember we briefly talked about those in the last unit? Or just in general, if you look at this formula, if my side length is x, then yeah, my area is x squared. If we're talking about a square. So that's step one. Finding the area of the large square. We really just want an expression though for the area of the shaded part. You see how it has these non-shaded squares cut out of it? We need to figure out, does that add or subtract to the shaded area? It subtracts from it. And we do know the dimensions of it. So if it's a square, that's 1 by 1. What's my area of the square? If it's about the bathroom, there's no time, so don't ask me. For this square, it is not an area of 4. It is not an area of 2 either. Length times width, 1 times 1, guys. Or since it's a square, 1 squared is still. Are we alive? Here to like even try a calculator even, if you can't do 1 times 1 or 1 squared, like, I don't know how to help you if we can't get past that basic information. I feel like we need to go back to 2nd grade. I guarantee you they know how to do this in 2nd grade. 1 times 1 is what? 1. So my area of the 1 square is 1, and how many squares do I have? So from that, we're subtracting 4 times 1, which is 4. All right, questions on that? With the rate that this is going, I don't think I'll have time to talk to you about figure B, so I'll let you figure that one out on your own. Maybe you need to do some deep diving. Remember some facts about squares, facts about how to find an area of a square before you come back to this problem. Questions at all before you go? All right, bell rings in 1 minute.